So in this video, let's talk about how we can determine the percent composition of different mixtures in some ionic bonds. And so let's say that I have something like Na atom right here, and then I have a Cl atom right here. And let's say that these two were in a bond, so they're bonded together. And if we were to go in and break this bond, so we were to break the bond right in here, what we would end up getting is we would get an Na atom right here, and then we would get this Cl atom over here. And let's say that we know that we have exactly 1 mole of this NaCl. Well, when we go to break this bond right in here, if we would break this bond, think about how many of moles of this one and then moles of this one that we would get. And for every one molecule of this we have, we're going to get the same number of atoms of this one and of this one over here. Because when this thing breaks apart, this Na is going to go over here, and then this Cl is going to go over here. So we actually end up getting the same number of moles over here. So this would be 1 mole, and this would be 1 mole. And you could think of it as these two right here are going to be smaller pieces, and this over here is going to be a large piece. And if we know how many we have of each one of these smaller pieces, we can determine the number of larger pieces we have over here. So let's say that we know that we have maybe like 2 moles of Na over here. Well, if we know that we have 2 moles of the Na, it's going to require 2 moles of the Cl, and when we have 2 moles of the Na and 2 moles of the Cl combined, we're going to get 2 moles of the NaCl. And so you can keep this in mind when you're working through these questions that involve mixtures of different ionic compounds. The number of moles of the smaller one, and how many of those it's going to take to equal this larger one over here. So let's see a problem that involves this. And in this problem, it says that we have a 2.5 gram mixture that contains NaCl, and we have this KCl. And if the sample contains this 0.56 grams of Na, we want to determine the percent composition of this Na right here. And so we're given a part of this smaller piece, Na, that's part of this NaCl. So when you do this problem, you could think of it as that we have NaCl, and then we have this KCl over here. And we know that we have this Na right in here. So if we know that this small piece right here, that's part of the NaCl, we can figure out the piece of this that goes together. And from there, we can figure out the percent composition, because a percent composition, the equation for that is going to be that the percent is going to equal the amount divided by the total times 100. And so for this amount and the total, we're going to use grams for that. It's useful to have to use molar mass for equations like this, but that's going to be for compounds that are not in a mixture. And so let's do this. Let's take the 0.56 grams of Na, and what I want to do is I want to go from a gram to a mole. And so I'm going to divide this right here by the molar mass of Na, and that's going to be 23. So I'm going to do 0.56 divided by 23, and I'm going to get 0.0252, and that's going to be moles of Na. And now that I'm in moles of this Na, I'm going to go from moles of Na to moles of NaCl. So I'm going to take the 0.0252 moles of Na, and what I'll do here is I'm going to say that for every 1 Na that I have, I'm going to have 1 NaCl. And then what's going to happen is the Na here and the Na here will cancel out. And so that means that we're going to get 0.0252 moles of the NaCl. And so now that I'm in moles of NaCl, I need to go to grams. I'm going to take this 0.0252 moles of the NaCl, and I'm going to multiply it by the molar mass of NaCl, which is going to be 58. So when I do this number times 58, I'm going to get 1.46, and this will now be grams of NaCl. So now that I'm in grams of the NaCl, I know what this number is. I know the total is going to be 2.5. So all I have to do is, we'll just do the 1.46 divided by the 2.5, and then we multiply it by 100, and we're going to get that this will be 58.5% NaCl, and the mixture that has NaCl with this KCl. So this one would be 58.5%, and the rest of the percentage must be this KCl right in here. And so now let's try to do another problem kind of similar to this. So in this question, it says that a mixture contains MgCl2 and KCl, and if the mixture contains 70% Cl by mass, determine if the MgCl2 or the KCl has a higher amount by mass in the mixture. And so what I'm going to do is I'm going to take this MgCl2, and then I'm going to take this KCl right in here, and what I'm going to do is I'm going to figure out if I have nothing but MgCl2 in the mixture, what's the percent of this Cl right in here. And so what I'm going to do is I'm going to take the MgCl2, and then I'm going to take the KCl right in here, and I'll figure out the percent composition of Cl in both of these chemicals. Now, the reason why this problem is different from the last one is because we're given the percent right here of the Cl, and so if we know the amount of Cl right in here, that's not going to help us because we have Cl here and we have it here. We have it in both of these. And so in the last problem, they just gave us something like Mg, and from Mg we could figure out how much Cl2 is within this Mg. But because this Cl right here that we're looking for is in here and it's in here, it's in both of the chemical compounds, we're going to have to approach this problem a little bit differently. And so let's go ahead and find the percent composition of the Cl2 and the Mg right here. So to find the percent of Cl, we're going to do the equation that a percent is going to be equal to the amount divided by the total times 100. And so what I'll do here is say that I have 2 Cl's, and the molar mass of 1 Cl is going to be 35, and then I have the total molar mass of the MgCl2 is going to be 95, and when I take these two and divide them and then multiply by 100, I'm going to get that this is going to be equal to 73.68%. And so this would be the percent of the Cl in the MgCl2. And so now let's do the same thing for this KCl over here. And so for KCl, I'm going to take that I've got 1 times 35 because I only have 1 Cl in here, and I'll divide it by the total molar mass of KCl, which is going to be 74, and then I'll multiply that by 100, and I'm going to get this is equal to 47.29%, and that's going to be of Cl. And so what we have here is we have this MgCl2 is 73.68%, and the KCl is 47.29%, and in the mixture we have 70% Cl. So what we'll do here is just we can do like a percentage line, and over here I can represent the 73.68% Cl, and that's going to be the MgCl2, and then over here I can represent the 47.29% Cl, and this will be the KCl over here. And so what I need to do is I need to figure out the number that's going to be in the middle of these. And to do that, I'm going to just take the average of this one and the average of this one, and that'll be right in the middle right in here. And so when we do, let's see, we'll do 47.29 plus 73.68, and we'll add those up and then divide it by 2 to get the average, and that's going to be 60.4%. And so this right here would be 60.4% right in the middle, and because this 70 over here is going to be more on this side over here, it means that the higher amount is going to be this MgCl2. So the MgCl2 is a higher percentage by mass in this mixture that has MgCl2 and this KCl. So now what I want to do is I want to talk about the proof for how we know that this is correct. And so this is kind of a longer way to think about this problem, but let's go ahead and do that so you can get a better understanding of what's going on in this question. So I'm just going to make up some numbers, and let's say that I have 50 grams of MgCl2, and what I want to do is I'm going to also have 50 grams of this KCl over here. And so if I have 50 grams of both of these, then let's find the percent composition of Cl in a mixture that has this amount of MgCl2 and this amount of KCl. And if we get the percent composition of this Cl, it should equal the 60.4 that we got. And so what I'll do here is I'm going to first take this 50 grams of the MgCl2, and I'm going to divide by the molar mass of MgCl2, and that's going to be 95. And so when I do 50 over 95, I'm going to get 0.5, let me see, 0.5263, and this would be moles of MgCl2. And now what I'll do is I'm going to go from moles of this chemical to moles of just the Cl, and so I'm going to have 0.5263 moles of MgCl2, and I'm going to say that for every 1 MgCl2, I'm going to have 2 Cl's. And so I'm going to take this number and I'm multiply it by 2, and I'm going to get that I'll have 1.052, and that'll be moles of Cl. And I want to go from moles of Cl to grams of Cl. So I'm going to take this number and then I'll multiply by the molar mass of Cl, which is going to be 35. And so we're going to take these two numbers and multiply them, and that's going to be equal to, we'll have 36.842, and that'll be grams of Cl. So this is how much in grams of Cl I'm going to have, and 50 grams of MgCl2. And so we'll do the same thing for this KCl. I'm going to take 50 grams of KCl divided by the molar mass, which would be 74, and that's going to be equal to 0.6756, and that'll be moles of KCl. And so I'm going to take 0.6756 moles of KCl, and what I'll do now is I'll say that for every 1 KCl, I'm going to have 1 Cl atom, and so that would be equal to, we'll do 0.6756, and that'll be moles of Cl. And so I want to go from moles of Cl to grams of Cl, so I'll multiply it by the molar mass, which is going to be 35, and that's going to be equal to 23.64 grams of Cl. And so now to get the percent composition of the Cl, what I'll do is I'm going to take the 36.84 and I'll add it to this one right in here, and so that will be 36.842 plus 23.64, and when I add those up, that would be 60.4 grams of Cl. And so if I have 60.4 grams of Cl divided by the total grams of this entire sample, which would be 50 here and 50 here, so that'll be 100 grams times 100. That's going to be 60.4 percentage. And so this would be the percent of Cl in this mixture right in here. And notice that this number right in here is going to be the same percentage that we got earlier. And so that's how you're going to find the percent composition of different mixtures that have ionic bonds.